Getting everything set up, doing a quick audio test before I get the show started. Today's going to be another episode of The Cut, just so everybody knows. Waiting for number to kick in. Sounds good on kick. Hopefully today I actually had the live stream on Wonderful World of Weirdness. Last night I put it on the wrong channel, so I had to redo all that on YouTube. Okay, sounds alright on YouTube. It's weird in that background noise, but I don't know if I can get that out. Sounds good on D Live as well. Now I have to go over and check Twitch, see if it's working. Okay. Sounds good on Twitch. Hit refresh on Rumble. It still hasn't kicked in yet. Sounds like it's actually. Sounds good on Rumble. Okay, so we are good to go. So, here in a minute, after I take a drink of my soda, I'm going to start the episode, do my introduction, and then go into the topic. Hello, everybody, and welcome to another episode of The Cut. Today is the 7th episode, I believe. I have got my my story set up, I guess you could say, for this episode. Hopefully, they'll be longer than what they were before. I was really surprised by that last week whenever I did do my last episode. It was kind of short. Hopefully, this is a lot longer. I really would like to. I really don't know what to say about this week. I can't really say it was a setback, but I can't really say that it was a step forward. I ended up having to cancel a stream that I did or was supposed to do yesterday. But that's okay. I didn't have, or I'm actually ahead on that one, so I can do that next week. Been having some uh, technical issues and stuff of that nature, so we can get to it when we need to get to it. So with that being said, I'd like to welcome everybody to the show and get on with the talking points, or with talking points, I guess. So here we go. In the years following the Roman withdrawal from Britain, the land lay fractured, a patchwork of territories claimed by ambitious warlords. Among them, Vertigern rose with cunning and ambition, determined to secure his rule over a people weary of chaos. He selected a high hill on the Welsh mountains as the site for a great tower, envisioning a structure that would symbolize power and endurance for generations. Yet despite careful planning and skilled masons, the tower refused to stand. Stones crumbled, walls collapsed, and the king's frustration grew with every failed attempt. Advisors whispered of curses, spirits, and the anger of the land itself. One spoke of a prophecy: only the blood of a boy born without a father could anchor the foundation and prevent it from falling. Skeptical, yet desperate, Vortigern dispatched envoys to search the land. Months passed with no sign of such a child, and the tower continued to fail, casting doubt upon both prophecy and power. At last, word arrived of a boy in a remote part of North Wales, mysterious in birth, whose father was unknown. He was brought to Vertigern's court, where the boy's presence radiated an aura of calm and certainty. Unlike other children, he showed no fear. Instead, he laughed softly at the court's insistence on prophecy. "I know why your towers fall, king," he said. "It is not the stones or the mortar, nor any curse. Look beneath the foundation, and you will find the truth." The court erupted. "Impossible," one adviser cried. "We have found the child, yet our work still fails." The boy shook his head. "You misunderstood. Dig deep beneath the hill, and the earth itself will reveal what you cannot see from above." Vertigern ordered the excavation. As workers dug, they uncovered a hidden pool beneath the hill. From its depths emerged two dragons, one red and one white, coiled in silent tension. The court gasped. "The white dragon represents invaders who will seek your lands," the boy explained. "The red dragon represents your people, their struggle in the mirror of your kingdoms. No, their struggle is the mirror of your kingdom's fate." The dragon stirred, and the water rippled with power. The red dragon struck the white fury with fiery precision. The white lunged back, scales glinting like frost. The ground quaked under the weight of their conflict, yet the boy remained calm. "Fear not what you see," he said. "The red dragon fights for home. The white dragon fights for conquest. Observe and understand the balance that governs all." Vortigern turned to the boy. "Who are you?" "I am Merlin," he replied simply. "I see what others cannot. I guide those willing to understand that power without wisdom is fragile. The king's pride battled with me. The king's pride battled with awe. Tell me, how may I build my tower to endure?" Merlin raised a hand. "The tower is not merely stone and mortar. Its foundation is its foundation is truth, patience, and respect for forces unseen. Dig deep, learn from what lies hidden, and act with wisdom. Only then will the tower and your kingdom stand." Days passed. Vortigern worked alongside the masons, observing the water, the stones, and the reflections of the dragons. He spoke often with Merlin. "Why do the dragons fight?" Merlin's eyes gleamed. "The struggle mirrors life itself. One fights for legacy, the other for dominion. Learn from them. Your tower is a metaphor for leadership. Strength arises from perception and understanding, not fear or haste." The court, once skeptical, began to murmur. Some saw the wisdom, others clung to old fears. "Must we wait for the earth to speak?" one said. "Patience is the key," Merlin said. "Haste builds only weakness. Strength grows from comprehension." Finally, a breakthrough occurred. One misty morning, the dragon's reflection merged into a calm image, the earth settling beneath the foundation as if acknowledging the king's readiness to learn. Vortigern felt a surge of awe. "The foundation will hold," he whispered. Merlin nodded. "Not just the stone, but the understanding that shaped it. You have learned, king." The masons resumed work, laying stones carefully, measuring mortar precisely. The tower rose steadily, each level a testament to patience, knowledge, and harmony with unseen forces. The dragons vanished beneath the pool, leaving only faint ripples as reminders. Vortigern watched the completed tower, humbled and thoughtful. "I see now," he said, "that ambition alone is fragile. True struggle comes from insight and respect for the forces that shape the world." Merlin approached, voice soft yet commanding. "Remember, king, the tower stands because you learned to see beyond the obvious. Lead with wisdom, and your kingdom will endure." Years passed, and the boy, who had no father, now known as Merlin, became a figure of legend. The tower remained a symbol not of hubris, but of understanding and foresight. The pool, hidden beneath the fountain, held silent witness to the lessons imparted and the dragons that had guided the king. Vortigern often reflected upon these days, recalling the tremors beneath the hill, the struggle of the dragons, and Merlin's calm instruction. He understood that leadership required both courage and insight, and that the unseen forces of the land, the people, and even destiny itself demanded respect. The story of Vortigern, the boy without a father, and the dragons endured for generations. It reminded all who heard it that ambition, untempered by wisdom, leads to ruin, and that even the mightiest king must learn to observe, to listen, and to act with knowledge and patience. From the hills of Wales, mist curling over ancient stones, the legend whispered to those willing to hear it. The strength is born of understanding. That guide that guidance often comes from the unexpected, and that the true foundation of any endeavor is not merely in what is seen, but in what is recognized beneath the surface. And so the Tower of Vortigern stood, not as a monument to pride, but as a lasting testament to the power of perception, the guidance of a boy who required no father to wield wisdom, and the enduring truth that balance and insight can shape both kingdoms and hearts alike. Jupiter, the fifth planet from the Sun, is the largest in our solar system. Its sheer size and presence makes it a defining member of the planets orbiting our star. Situated beyond Mars and the asteroid belt, but before Saturn. Jupiter dominates the region of the outer solar system closest to the inner terrestrial planets. Its mass is so immense that it is more than twice the combined mass of all the other planets. Observing Jupiter from Earth, even with modest telescopes, one can see its distinctive bands of clouds stretching across its vast atmosphere, moving in patterns shaped by powerful winds and enormous storms. The planet completes a revolution around the Sun approximately every 12 Earth years, following a slightly elliptical orbit that keeps it at an average distance of nearly 800 million kilometers from the Sun. Its rotation, however, is astonishingly fast. A single day on Jupiter lasts roughly 10 hours, making it the fastest spinning planet in the solar system. This rapid rotation, coupled with its immense size, flattens the planet slightly at the poles, creating a noticeable bulge at its equator. The effect of this spin on its atmosphere is evident in the alternating bands of light and dark clouds, composing primarily of hydrogen and helium, interspersing with trace amounts of methane, ammonia, and water vapor. Jupiter is renowned for the Great Red Spot, a storm larger than the Earth itself, which has been raging for centuries. This storm, visible even with small telescopes, moves counterclockwise and represents the incredible forces at play within Jupiter's atmosphere. Surrounding the planet are numerous smaller storms and vortices, forming a dynamic and turbulent environment that is unlike anything experienced on Earth. Winds in the upper atmosphere can reach speeds of hundreds of kilometers per hour, shaping the planet's colorful belt in zones that give Jupiter its signature appearance. The planet's gravitational influence extends far beyond its own atmosphere. Its immense mass affects the orbits of surrounding celestial bodies, including the asteroid belt and the paths of comets that enter the inner solar system. Jupiter's presence has historically shielded Earth and the inner planets from many potential impacts, acting as a gravitational protector by attracting or deflecting objects that might otherwise collide with our world. This role in shaping the architecture of the solar system underscores its importance not merely as a planet of striking appearance, but as a key actor in the broader dynamics of our celestial neighborhood. Jupiter's moon, a collection of more than 70 known natural satellites, add another layer of fascination. Four of these, the Galilean moons, discovered by Galileo in the early 17th century, are particularly noteworthy. Io, Europa, Ganymede, and Celeste each display unique characteristics. Io is volcanically active, with eruptions that dwarf those on Earth, while Europa's icy surface suggests a subsurface ocean that could harbor conditions for life. Ganymede, the largest moon in the solar system, even exceeds Mercury in size, and Celestos' heavy cratered surface speaks to a long history of cosmic bombardment. These moons orbit Jupiter in complex patterns, locked into gravitational interactions that create tides, heat internal layers, and shape the evolution of these distant worlds. The name Jupiter itself carries a rich cultural and historical legacy. In Roman mythology, Jupiter was the king of the gods, ruler of the heavens, and master of thunder and lightning. This connection to the divine was fitting for the largest and most dominant planet in the sky, whose presence dwarfs all others and commands attention. The ancient Greeks knew this same planet as Zeus, their chief deity, and cultures across the world have often associated it with power, authority, and awe-inspiring influence. Even today, the name Jupiter evokes images of strength and grandeur, linking our scientific observation to the mythological imagination of our ancestors. Modern scientific explorers have further revealed the mysteries of Jupiter. Spacecraft such as Pioneer, Voyager, Galileo, and Juno have approached and studied the planet, providing detailed observations of its magnetic field, radiation belts, and atmospheric composition. Jupiter possesses the strongest magnetic field of any planet in the solar system, creating immense radiation belts that make close observation challenging. Its core is believed to be composed of dense metallic hydrogen and possibly a rocky center, though the exact structure remains a subject of ongoing study. Juno's polar orbits have allowed scientists to peer beneath the cloud tops, revealing patterns of atmospheric circulation, massive cyclones at the poles, and intricate auroras caused by the interaction of charged particles with the magnetic field. The story of Jupiter is not merely one of size and storms, but of cosmic relationships and influences. Its gravitational pull shapes the path of countless objects. Its moons hint at possibilities for life, and its turbulent atmosphere provides a natural laboratory for understanding fluid dynamics on a planetary scale. Scientists continue to marvel at its complexities, asking questions about how much a massive planet formed, how it continues to evolve, and what its role might be in the broader history of the solar system. Jupiter's story is intertwined with ours, from its influence on the early formation of planets to its ongoing effects on comets, asteroids, and even Earth's own stability. Throughout human history, Jupiter has inspired observation, myth, and curiosity. Early astronomers charted its movements with naked eyes, careful records allowing for predictions of its retrograde motions and conjunctions with other planets. With the invention of telescopes, observers noticed its rotating cloud belt, the shadows of its moons crossing its disk, and the relentless churn of its storms. Galileo's observations of the four largest moons in the early 17th century challenged the prevailing notion that all celestial bodies revolved around Earth, making a turning point in the scientific understanding of the heavens. Even today, Jupiter continues to shape human thought, both scientifically and culturally. It its presence reminds us of the scale and complexity of the solar system, of the power of gravity to bind worlds together, and of the mystery that lies in the storms and bands of an alien atmosphere. Astronomers study its radiation, atmospheric chemistry, and magnetosphere to understand planetary physics on a scale impossible to replicate on Earth. Educators use it to teach about orbital mechanics, the conservation of angular momentum, the interplay between mass, gravity, and energy in shaping planetary environments. The swirling clouds of Jupiter, with their vibrant red, orange, and brown or browns, evoke a sense of both violence and beauty. The great red spot, a storm larger than Earth, serves as a reminder of the sheer power present in the universe, while the icy moons orbiting quietly in the darkness hint at calm and stability among chaos. Each aspect of Jupiter, its size, its storm, its magnetic field, and its moons, provide lessons about physics, chemistry, and the history of the solar system. The, the orbit of Jupiter, completing a revolution around the Sun every 12 years, is stable yet slightly elliptical, demonstrating the principles that govern celestial mechanics. Its distance from the Sun means that the intensity of sunlight is far weaker than on Earth, yet its reflective clouds scatter and diffuse light, creating a planet that shines in the night sky as a beacon of size and power. Observers on Earth have used its ancient calendars, no, has used its motion and position. Okay, observers on Earth have used its motion and position to calculate the lengths of months and years in ancient calendars, further linking the scientific with the human experience of time and cycles. Jupiter's influence extends beyond the solar system itself. Its strong gravitational field shapes the Oort cloud and the paths of comets, serving as a guardian for the inner planets. Occasionally, the planet captures passing asteroids or deflects potential impacts, demonstrating the dynamic interplay of forces that govern planetary motion. Its study provides insight into the formation of gas giants in other star systems, informing the search for informing the search for exoplanets and the understanding of how planetary systems evolve over billions of years. The name of Jupiter and its mythological resonance continues to inspire writers, artists, and scientists alike. To ancient Romans, the planet represented divine authority and cosmic order. To modern observers, it is a laboratory of physics and a window into the process that governs giant planets. The continued exploration of Jupiter with spacecraft, telescopes, and computer simulations ensures that its story remains relevant, bridging the gap between the myths of old and the scientific inquiries of today. Jupiter, the king of planets, reminds us of the majesty and scale of the cosmos. Its storms, its rapid rotation, and its moons reveal the complexity of planetary formation and dynamics. Its orbit, steadfast yet elliptical, demonstrates the precision of gravitational law, while its magnetic field and radiation belts illustrate the power inherent in celestial bodies of immense size. From ancient mythology to cutting-edge space exploration, Jupiter stands as a symbol of awe, wonder, and scientific curiosity. Through the lens of history, astronomy, and mythology, Jupiter teaches lessons about observation, patience, and the pursuit of knowledge. Its presence in the solar system continues to shape our understanding of planetary science, from the behavior of gases under extreme pressures to the gravitational forces that sculpt orbits and collisions. The gas giant embodies the power of nature on a scale unmatched in the solar system, inspiring generations to look upward and seek understanding in the swirling bands of clouds and the silent dance of its moons. Even as space agencies plan missions to study its atmosphere, interior, and moons in greater detail, the legacy of Jupiter is secure. It remains a constant, a monumental presence in the night sky, reminding humanity of the beauty, power, and mystery of the universe. Every observation, every mission, and every scientific insight draws us closer to comprehending the forces that shape not only Jupiter, but the solar system as a whole. Thus, Jupiter, for from its mythological roots to its scientific significance, endures as a central figure in our understanding of the cosmos. It teaches about gravity, energy, and motion. It inspires curiosity, imagination, and respect for the power inherent in the universe. To gaze upon it is to witness a planet that is both violent and magnificent, a king of planets whose story has shaped human thought for millennia and whose lessons will guide us into the future of space exploration. Robert Hooke was a 17th-century English scientist whose contributions span multiple fields including physics, astronomy, biology, and architecture. He is often remembered for his pioneering work in microscopy, his formulation of Hooke's law of elasticity, and his experiments with air pressure and combustion. Hooke's curiosity and inventiveness made him one of the leading figures of the scientific revolution in England, yet his life was marked with controversy, personal rivalries, and disputes over intellectual credit. His work often intersected with that of other prominent scientists of the period, leading to disputes over priority, recognition, and publication. One of Hooke's most famous contributions is his work with the microscope, published in his book, which detailed observations of cells and microscopic structures. He was among the first to use the term cell to describe the basic units of life, based on the compartmentalized structures he observed in cork tissue. His detailed illustrations and descriptions showcase not only his scientific skill, but also his talent as an observer and communicator. However, his meticulous work also made him a target of dispute, as other scientists sometimes attempted to claim similar discoveries or diminish his contributions. These disputes often involved issues related to authorship, priority, and intellectual property in an era before modern copyright laws were established. Hooke was known for being meticulous about recording his experiments and ideas, often keeping detailed notebooks and correspondences. Despite this, he faced challenges in securing credit for his inventions and discoveries. The 17th century was a period of intense competition among scientists, and Hooke was involved in several disputes with contemporaries over claims of priority. In many cases, other scientists published similar findings without acknowledging Hooke's prior work, leading him to engage in spirited arguments to defend his reputation. These conflicts illustrate both the collaborative and competitive nature of early modern science and the difficulties of establishing intellectual ownership in a rapidly evolving field. One of the most well-known rivals in Hooke's life was with Isaac Newton. Their conflicts were multifaceted, encompassing issues of scientific priority, personal animosity, and institutional influence. Hooke and Newton clashed over the nature of light, planetary motion, and the inverse square law of gravitation. Hooke claimed to have proposed ideas about the law of attraction between bodies before Newton published his monumental work on gravity. Newton, who was often sensitive to criticism, responded aggressively to Hooke's claims, and their correspondence reflected a mixture of professional debate and personal antagonism. The rivalry was further complicated by Hooke's position within the Royal Society, where he served as curator of experiments and held considerable influence in the early scientific community of London. In addition to disputes over scientific ideas, Hooke engaged in conflicts related to architectural projects and engineering innovations. He collaborated with notable figures such as Christopher Wren on the rebuilding of London after the Great Fire, contributing knowledge of materials, structural integrity, and urban planning. Yet even in these professional partnerships, tension arose regarding credit and recognition, as Hooke's contributions were sometimes overshadowed or minimized by more prominent colleagues. These recurring disputes highlight a pattern in Hooke's life. Despite his intellectual brilliance, his strong personality and insistence of recognition often led to friction with peers. After Hooke's death, his legacy continued to be affected by disputes and erasures. One notable event involved the disappearance of his portrait, which was reportedly missing from the Royal Society in the years following his death. This loss coincided with Isaac Newton's ascent to leadership within the society, and some historical accounts suggest that the removal or neglect of Hooke's image reflected the tension and personal rivalries that had defined their interactions. Hooke's absence in the visual records has contributed to a historical narrative in which his contributions were sometimes overshadowed by the fame of Newton and other contemporaries. Hooke's involvement in the intellectual disputes also extended to questions of copyright and publication rights. The 17th century did not have formalized copyright laws in the modern sense, but dispute over the ownership of ideas, drawings, and experimental findings were frequent. Hooke was vigilant about publishing his own work and defending it against perceived plagiarism or misattribution. He engaged in heated correspondence and public argumentation to assert his claims, emphasizing the importance of establishing clear recognition for scientific contributions. These conflicts reflect broader tension in the early modern scientific community regarding the sharing of knowledge, priority of discovery, and the emerging norms of professional conduct. In his scientific work, Hooke demonstrated an extraordinary range of interests. In physics, he formulated the law of elasticity, demonstrating that the force needed to extend or compress a spring no, demonstrating that the force needed to extend or compress a string is proportional to the distance of deformation. This principle became fundamental to the mechanics and materials science. He also conducted experiments on air pressure, vacuum, and combustion, laying groundwork for later studies in thermodynamics and fluid dynamics. His meticulous approach to measure and experimentation reflected a commitment to empirical observation, which was central to the ethos of the scientific revolution. In astronomy, Hooke made significant contributions to the observation of planetary motion, the study of Jupiter's moons, and the identification of comets and other celestial phenomena. His collaboration with other scientists in tracking the movements of celestial bodies, often employing innova- in- innovative instruments and observational techniques. Yet even in these endeavors, dispute arose regarding priority, particularly when other astronomers published findings that resembled Hooke's work. His insistence on proper attribution sometimes led to strange or strained relationships and ongoing debates about the ownership of knowledge. Hooke's architectural and engineering work further illustrates the breadth of his expertise. Following the Great Fire of London, he collaborated on the design of buildings, bridges, and urban infrastructures, applying scientific principles to practical problems. He studied materials, load distribution, and structural stability, combining empirical observation with theoretical reasoning. While his contributions were significant, his role was frequently minimized in historical accounts, often overshadowed by the fame of collaborators or the subsequent rise of Newton and others within the Royal Society. The rivalry with Newton reached its height over the topic of gravitational and planetary motion. Hooke claimed to have formulated the concept of an attractive force between bodies and even proposed a specific law, which Newton later published in his work on universal gravitation. Newton's subsequent prominence and careful cultivation of his own intellectual reputation contributed to a perception that Hooke's contributions were secondary. Despite evidence that Hooke had been an active and influential theorist, this episode exemplifies the complex interplay of personality, ambition, and scientific discovery in the early modern period. Hooke's disputes over intellectual property, priority, and recognition also extended to his contemporaries beyond Newton. He had contentious relationships with other leading figures, engaging in debates over experimental methods, interpretations of data, and claims of invention. His insistence on precise documentation and his aggressive defense of authorship reflected both his confidence in his own ability and the broader struggle within the scientific community to establish norms of credibility and acknowledgement. These conflicts highlight the challenges faced by pioneering scientists operating in a competitive and rapidly evolving intellectual environment. Despite these conflicts, Hooke's contributions were foundational for numerous scientific disciplines. His observations with the microscope opened new avenues for biological research. His experiments with air and elasticity informed later studies in physics and engineering, and his work in astronomy advanced understanding of the solar system. His methodological rigor and insistence on empirical verification established standards that influenced generations of scientists. Hooke's legacy, though complicated by rivalry and historical neglect, demonstrates the enduring impact of his inventive mind and multifaceted expertise. Hooke's personality also played a role in shaping his scientific career. He was known to be irritable, argumentative, and sensitive to criticism, traits that fueled his disputes but also reflected his passion for discovery and recognition. Contemporary accounts describe him as brilliant yet combative, a combination that made collaboration both productive and fraught. His careful documentation of experiments, detailed illustrations, and theoretical insights testify to his intellectual ambition and meticulous approach to science. The disappearance of Hooke's portrait and the overshadowing of his achievements after his death serve as a symbolic reminder of the challenges he faced in securing recognition. With Newton's rise to prominence, Hooke's contributions were often minimized or overlooked, contributing to a historical narrative that emphasized other figures in the scientific revolution. Modern scholarship has worked to restore appreciation for Hooke's innovations, highlighting his role as an essential contributor to the development of experimental science. In reflecting on Hooke's life, it is clear that his story embodies both the triumphs and challenges of pioneering scientific work. He advanced knowledge across multiple fields, uh, innovative introduced innovative methodologies, and engaged in rigorous empirical investigation. At the same time, his career was marked with disputes over credit, intellectual property, and professional recognition. His rivalry with Newton and other contemporaries underscores the intensity of scientific competition in 17th century England, while the post-humanist neglect of his portrait symbolizes the complexities of historical memory. Hooke's work remains influential today. The principles he formulated in elasticity, microscopy, and experimental methodology continues to inform scientific practice, while his approach to careful observations and rigorous measurement serves as a model for empirical inquiry. By examining the challenges he faced in securing recognition, modern scholars gain insight into the dynamic of scientific discovery, the importance of intellectual attribution, and the human dimensions of research. Hooke's life and work thus offer a rich case study in both the development of science and the personal and institutional struggles that shape historical legacy. Robert Hooke was a brilliant and versatile scientist whose contributions spanned physics, biology, astronomy, and architecture. His work on elasticity, microscopy, and air pressure established foundational principles for modern science, while his careful documentation and empirical methods amplified the rigor of the scientific revolution. His life was marked by intense rivalry, particularly with Isaac Newton, and by disputes over priority, recognition, and intellectual property. The disappearance of his portrait and the overshadowing of his legacy illustrates the challenges he faced in securing lasting knowledge. And with that being said, I just have to say one thing. Isaac Newton stole it. He's a thief. He stole Robert Hooke's portrait. Just saying. I mean, the evidence there. So, with that being said, that is the end of my talking points. I hope you guys did enjoy. If you did, I ask you to like, subscribe, share, make comments. Love to hear your feedback. And I do have a comment from somebody on YouTube. Susan Does Jordans says, I have no thyroid, but my daughter has Hashimoto's. Hashimoto's. It's very interesting. So, yeah, hopefully, hopefully we can maybe talk about that later on. I know a few people who's had issues with thyroid problems, and some of the complications that are involved in that. So, if you guys are into stuff like that, I do suggest that you check out another channel that I do have. It's smaller than the Wonderful World of Weirdness or Strange Stories, but it's still my channel. It's called Earth. I usually have, I believe I have it posted on the front page of the Wonderful World of Weirdness on YouTube. So if you guys want to check that out, go check it out. And maybe I'll get back to that and do an article and a stream concerning the thyroid. So thanks for making a comment, Susan. We do appreciate that. And with that, I will go ahead and say, if you like the stream, please like, subscribe, share, make comments, give some feedback down in the comment section. It's cool to get stuff in chat too, like we did just now with Susan, but the comment section is really important too. That sticks around after the stream is finished. So if you could go in there, make a comment, say hi if nothing else, and let everybody know how you're doing. If you do make a comment, I will respond. I guarantee you that. I always respond. So do me a favor and do that. Just so everybody knows, this is being streamed on the Wonderful World of Weirdness on both Rumble and on YouTube. It will the video will be edited and put also on my other channel besides the Wonderful World of Weirdness on YouTube, on Strange Stories, which is also on YouTube. At a later time, it'll be scheduled and put on there, so you can check it out on that channel as well. If you aren't on YouTube or on Rumble, you can also check me out on Infamous 1969 at Infamous 1969 on Twitter or Twitch. Sorry about that. And you can find me on Kick as well as DLive as Roger_Hansen. With that being said, we got to do it now is say thank you guys for watching. I hope you have a good day, and I will talk to you later. Bye.